Welcome again to Let's Talk Advanced Chemistry, Chemistry 2 with Pastor Dan. Today is the last day of our section on acid-base reaction. And we're looking at something called KSP. KSP is the solubility product constant, and the value is KSP. It is the measure of how much a salt dissociates. So we're talking about it right now because remember we said a salt is a product of an acid-base reaction. So let's do the example here of CuCO3. If we have CuCO3, it's going to dissociate into Cu2 plus CO3. So it's going to dissociate into its ions. When we find that KSP, and those are the charges, and both of those are going to be aqueous, when we do the value for the KSP, you'll notice there's only the products. There's no reactants. The reactants are not here because of the fact that that's a solid. Remember, we can't have a concentration of a solid. So for KSP, it's just the product side. The reactant side is not there because of the fact that it's a solid and we can't get a concentration for a solid. All right, there are two types of problems we can do. The first one, easier of the two. Calculate solubility constant for nickel 2 chloride. If the nickel ion concentration is 0.002455 molar, all right, so there is the dissociation of nickel. So for our KSP, balance it up. For our KSP, it's going to be nickel 2 plus ion plus chloride ion squared. Now, we know the nickel ion concentration. From the problem, we see that it's 0.002455. Now, we don't know chloride, but we do know the molar relationship. Nickel to chloride is 1 to 2. So if 0.002455 is the concentration for nickel, concentration of chloride is going to be double it because it's a 1-2 relationship, 0.004910. Take point on your calculator, 0.002455 times 0.004910 squared equal answer 4 sig figs. Answer is 5.919 times 10 to the minus 8th, and that's our answer. All right, that we can do anything we want there. If they're 2 to 3, we simply have to find the values. All right, now the other way that we can do this is if I know the KSP, and I know the ions, and I can find the concentrations. So let's start with an easy one. Let's do, and the KSP value is 5.0 times 10 minus 9. For barium carbonate, we're going to end up with... I'm going to pause here real quick. Like, when we do this, there's no sig figs here anywhere. So what we're going to do is we're just going to have the answer to 4 sig figs. Just make it easier that way. Barium 2 plus ion and carbonate 2 minus ion. They're 1 to 1, it's already balanced. So my KSP is going to be barium 2 plus ion times carbonate ion. Now, I don't know either of these values, so they're both going to be x. X times x, that's x squared. KSP value is 5.0 times 10 minus 9. So if I want to solve for x, I just simply take the square root of it. Square root of 5.0 times 10 minus 9th. X is going to be 0.00007071. That's going to be my concentration, my barium, and my carbonate. Remember, those are both X. And since they're concentrations, it's getting molar. That's my answer. All right. That's my answer there. All right. So let's do one last one now. Pause the video. Give this a shot. We're going to work through it. Remember, any questions, lts.pd@gmail.com. Remember, like, subscribe, share. Any questions, comments, I will refer back. Hopefully this helps. Ready? Here we go. Start through this. So KSP value is 1.6 times 10 minus 13th. Should have given that before. I apologize. Now, if you want to stop, work through it. Okay, here we go. That's my dissociation. That's my KSP. But because this is 2, this is going to be squared. We don't know the values. They're x and 2x, so we can plug those in. X times 2x squared, that's going to be x times 4x squared. X times 4x squared is 4x cubed. It's going to be equal to my KSP value. So this time we're going to divide by 4 and then take the cubed root. We get an x value of 0.00003420, and that's going to be my concentration of magnesium in molarity. To find my concentration of hydroxide, we said it was 2x. So 2 times 0.00003420 is going to be 0.00006840. Those are my values. And I did mention before, there's really no sig figs here, so you go to 4 just to make it easy to work with. All right, so we're going to practice tomorrow, and then we'll practice everything, and then acid base will be done. We're going to do nuclear, and then we'll see what else we can throw in there, maybe organic possibly, and modern materials, see how far it goes. Hopefully not too bad. Take care. God bless. Bye.